Hey everybody, it's Tony from Adafruit, and this is part 4 in the Raspberry Pi Talk to Wi-Fi Things series. And so this is probably going to be the last part of this series for now, but I'm sure I'll come back and do more videos on Raspberry Pi and little Wi-Fi boards. But just to kind of summarize, so we've done 3 videos already to kind of cover the topic of how do you have a Raspberry Pi talk to, like send messages and receive messages with a little Wi-Fi board. So like the ESP8266, the AT-Wink 1500, the WISID board. So all kinds of little Wi-Fi microcontrollers, and I'm sure there'll be a lot more, a year from now, they'll probably be covered with a whole new set of Wi-Fi boards. But there aren't a lot of good examples of how do you take a little Wi-Fi board and have it send and receive messages with like a Raspberry Pi or even your computer. And so that's what I've really looked at in this series. We started with the first couple videos looking at simple tools like Netcat that you can use to do real basic kind of socket connections and sending and receiving data. And then in the last video we looked at how to use Python to create a little socket server that can send and receive data with an ESP8266. And in this video, I was thinking, let's kind of look at a more practical example of, how you might want to implement devices talking to devices using the MQTT protocol. And so that's a really neat little protocol for devices to talk to each other. And I'll talk a little bit more about it. We'll look at kind of the webpage that kind of describes it. But it's a protocol that's been around for, I think, maybe 10 or 15 years now. So it's a little bit, it's not like it's a brand new thing. But it's really meant for like lightweight messages that are passed between devices. So there's a central server in MQTT called the broker, and everything connects to that broker. So you might have a little Wi-Fi board that connects to it. Your Raspberry Pi could connect to it, even though your Pi might also be running the broker itself. But everything connects to that central server. And then the server, it has a concept of a topic, which is just a string that identifies something. And you can send and receive messages to a topic. And so they kind of call it like a publish and subscribe model. So you could imagine if I wanted to maybe control an LED connected to an ESP8266, I can make a topic that's the ESP8266 LED topic and then send and receive messages on that. And this is, I think, a little more interesting and maybe more practical than the last video where we did kind of raw socket programming. Because with this, you don't have to create your own server. You can use an MQTT server, and I'll show you how to install one and use it. And that way you don't have to mess with all of the socket server programming, because in the last video we made a really simple socket server, but a real world socket server would be a little more complex. Like you're going to want to deal with lots of failure cases. What if your devices don't connect to it? If you want to deal with like authentication and all kinds of things like that. So it gets really complex really fast. And so this is more of looking at, okay, let's use an existing server technology like MQTT, and we'll use that server and then we'll write some little scripts that can connect to it and send and receive messages. And you can see this is going to be a little more scalable, a little more easy to extend in the future, because you run the server and then it's really just a matter of talking to the different topics that you create on the server. So let's just kind of dive in and we'll get started. I'll start with little demos. So we'll do I'll demo what we're going to build, and it's actually exactly the same as the last example that I did, or the last video. So in the upper right you can see I've got the exact same setup as in the previous video. So I have the Pi, and it's connected to a little push button right here, and there's an LED connected to it. And then over here is the ESP8266, the Feather Huzzah board, and then that's connected to an LED and a push button also. And the exact same thing as last time will happen. So when I press the button on the ESP8266, you see the light comes on the Raspberry Pi, and then similar with the Pi, when I press the button, the light comes on the ESP8266, and if I press the buttons again, it just toggles them. So it's you can press them both at once. Pretty simple, straightforward, but good demo of both devices talking to each other, passing messages around. It's pretty much the basis for how devices might talk to each other. Now you can see my code is running right here that we're going to implement, and it's just printing out as it receives messages and things. So I'll cancel out of this, and we'll come back to this in a second. So that's what we'll build here in this demo, and this is all based on MQTT. So I have a little broker that's running on the Raspberry Pi. That's basically the MQTT server, and the ESP board is connecting to it. And then when it wants to toggle the LED on the Raspberry Pi, it's sending a special message to the Raspberry Pi MQTT broker. And then on the Pi, I also have another script that's running, a little Python script that's connecting to the Pi itself. So the script on the Pi connects to the MQTT broker that's running on the Raspberry Pi, and then it's listening for those little messages from the ESP, and it's also listening to the button. And so when it gets that message, it'll send a message to the ESP board to tell it, hey, change your LED state here. And it's a little bit different than the last example because the last time we did it, we had a socket server running on the Raspberry Pi, and then the ESP board was also kind of running a socket server, or at least it was listening for connections. Whereas in this model with MQTT, only the Raspberry Pi is what's listening for connections. So both the ESP8266 board connects to the Raspberry Pi, and the Raspberry Pi, the Python script on there also connects to the Raspberry Pi. So like when I press the button on the Raspberry Pi over here, I'm not running the script anymore, when I press this button, it actually it doesn't connect to the ESP board, it just sends a message to the MQTT server, and then the MQTT server looks to see, is the ESP board connected to the server, and if it is, it sends it that message. So it's a little bit different in that if this ESP board wasn't connected to the MQTT server, it might not actually get that message. So like the Pi itself doesn't need to figure out where the ESP board lives, what IP address does it have, or use like multicast DNS. It's actually just waiting for the ESP board to connect to the server there. And we'll look more at kind of what that difference means, but it's got kind of an important distinction in that, in this model, everything connects to that central broker, and then it can send and receive messages, which has advantages and disadvantages. Like I think one advantage is that it's simpler. Your devices, the code that you write on the Pi doesn't need to know how to find and figure out where your ESP board is located. It's just going to assume that if that ESP board is online, it's going to be connected to that MQTT server and waiting to receive messages. So we'll look at that more in detail kind of as we get into the code for this. But just to start with, and again, I'll put links in the description below to all the previous videos in the series, and then any of the links that I mention and show, I'll put down in the description when this video goes up on YouTube. And just in general, so MQTT protocol, like I said, I won't go too deeply into this, but it's really meant as like a machine-to-machine, and I think it was the message queue transport or tunneling I can't remember exactly what it stands for, but basically it's kind of like a lightweight TCP-based protocol for sending and receiving messages between devices. So like I said before, it has this publish and subscribe model where clients can connect to the server and they can subscribe to changes on certain topics, and then when something wants to push out, like notify other clients of a change, they can publish a message on a topic. So everything is kind of topic-based in MQTT, which makes it really nice and really flexible, and that it's not imposing like this complex protocol on you where you have to like describe your devices in some way. It's really just strings. Like there's a string topic that can be as simple or as complex as you want it to be, and then the payload of that is just a bunch of bytes. It could be like another string message that you're sending there. So it's very lightweight, but it does have a lot of things that it implements in the protocol that the servers implement. So concepts of like, if a message is really large, it needs to be broken up across multiple packets, it can do that automatically for you. Or if like you want to guarantee the delivery of a message so that you ensure that some client is connected, and if it's not connected right now, maybe save that message and send it to them when they connect. So you can do really advanced things with MQTT, and we won't get too far into the details of this. I mean, this could probably be a whole nother series on itself. But by using this protocol and this and the servers and things that are pre-built for it, you get a lot of advantages over just writing your own raw socket code. There's a lot less stuff that you need to deal with here. So the mqtt.org webpage is pretty good, and then it gives you kind of the spec and a description of it. You probably don't want to read the spec to try to understand the protocol. The MQTT wiki page also kind of has maybe a few more details on it. So so it's message queue telemetry transport. So I think initially maybe it was used for like sending telemetry of like little devices around for it. So it's nice in that it's lightweight. So it's it's not this complex protocol like the web protocol, HTTP, Hypertext Transport Protocol. It started out really simple and lightweight and text based, but nowadays modern HTTP is pretty complex. I mean, like it can be encrypted, it can be compressed. There's like concepts like WebSockets and things. So it's over time protocols get pretty complex, but MQTT has stayed pretty simple because it's meant to be used on little low power devices like that we have right here. So let's see. Let's move on then, and let's look at. So we'll start with how do we get an MQTT server to run on the Raspberry Pi? Because like I said, everything in MQTT is based on a single server. You can actually have multiple, but you know, for the simple cases, you've got one server and everything connects to that server. Now, to create that server, luckily we don't have to write it ourselves. There's some really nice open source ones that are out there. And the one that I'll show how to use is one called Mosquito, which is a really nice MQTT server. It's kind of like the reference implementation that you know, has the latest details of all the current MQTT specs and protocols. And it's used in a lot of different places. Very easy to get it set up. So let's just kind of get started. So I'm connected to my Raspberry Pi right here, and I'll just kind of clear out where we are, and maybe I'll go back to the root of the Pi. So you'll want to boot up your Pi. You'll want to run the latest version of Raspbian Jessie, so like the latest version of the Raspbian operating system. And then do a sudo apt-get update, you know, just make sure your cache is updated of all your apt packages. And then we have a few different options here. So you could install the Mosquito server from the Raspbian repository. So they have a version in there, but it's a little bit of an older version. So if you go to the Mosquito webpage, I think it shows in here somewhere the latest version. Let's see. So yeah, the latest version is 1.4.8. I was just looking at it. I think it's like 1.3.2 that's in the Raspbian repository. So excuse me. So you know, you probably want to get the latest version from the Mosquito webpage instead of installing from the repository, just because, you know, right now it's reasonably up to date, but a year from now it's probably going to be really out of date. So luckily they make it easy though. So in the download page for the Mosquito webpage, they mention if you're using the Raspberry Pi, you can set up this Debian repository. They have an apt package source where they basically give you the latest build of the Mosquito MQTT server, and it's really easy to install. You can apt-get install it, but you just have to do a little bit of setup to tell it about this apt repository that they've created. So the steps will just follow exactly the steps they have here. So you want to get this little GPG key, because basically the Debian repositories, they're pretty secure. They use like signatures and keys and things to make sure that you're actually getting the code that you expect to get. So you download their key, and then you add this key. So there's this sudo apt key add command that I want to run. So I'll just, you know, I'm just copying and pasting, just running all these directly. Then after you do this, you want to yeah, now you need to actually load in their repository. So you go to this etc apt sources list.d directory. So if I go in here, and you can see inside of here, I've actually already loaded it. But this is where you can drop these little list files, which I don't know, let's see what they have inside of there. So this just defines, like, these are different apt package repository sources. So this raspi.list is kind of the main Raspbian package repository. So their instructions here just say, okay, now we want to download their mosquito.list file, and you want to pick for the right version of Debian or Raspbian that you're using. And so for the Jessie operating system, which is the current Raspbian release, you want this mosquito jessie.list file. So we want to download this into this sources.list.d directory. So this just uses the wget command. So pretty simple. And then the last little step, or actually two more steps, you want to do an apt-get update command. And I'm not going to run this because it takes a little while. When I'm streaming, my bandwidth is lower. So you just want to run sudo apt-get update. That's going to update all your packages. And then at this point, now you can actually do a sudo apt-get install mosquito. And this will install the Mosquito web server, or MQTT server. And it's going to install it from the later version that's in the Mosquito apt repository that we just added here. So it's, you know, just a little bit of like a one-time setup that you need to do for this. And it's good to go. Oh, well, it looks like when I downloaded that file in here, interesting. I downloaded it, created a .1 file, which this doesn't like. So I'm just going to delete this. You know, you won't have to deal with this because you won't have that file already. Oops, I have to sudo rm the .1 file there. So okay, so. And then now when I install Mosquito, it's actually going to tell me I already have it installed, so there's nothing to do here. Now, after you install Mosquito, it's pretty much running. It's ready to go, and you can actually see that. So again, they use systemd. That's kind of the modern way to manage services, and you can look and see. You can run systemctl status mosquito.service, and this will tell you about the Mosquito server. So it's loaded. and it's running. So it's actually going. And it actually kind of shows you, it's interesting, they show the process that's running right here. So there's the Mosquito process, and it's running with this -C option that's pointing at a configuration file. And this etc Mosquito directory is kind of interesting. So let's go into there. And this is where all of the configuration for Mosquito lives. So you can see there's a lot of stuff you can tweak inside of here. So this mosquito.conf we could see is what the server is actually using. Now it kind of tells you if you have your own custom configurations to place them into the etc mosquito conf.d directory. This is kind of a convention that a lot of Debian software uses, where it has like a main configuration file and then it points to a directory where you can put in your own custom configuration files. So that way you don't have to like modify that main configuration file. You just drop in your own configuration files to this directory. So it follows that same model. And then this just kind of has some setup in here that you really don't need to touch, but tells it to look at that directory. So then if I look into that conf.d directory in here, you'll see there's actually nothing in here. Well, I guess there's a readme, so we can look at the readme, which just kind of tells you can place your .conf files in here. So kind of by default, it doesn't have any special configuration, and so it's just running in like a default state. And luckily that state is permissive enough that we don't need to do anything to start using this server. It's actually listening and it's ready to go. So we can connect to it and start sending and receiving MQTT messages. Now that's a good thing that it's simple, but you should also realize like the way this server is configured right now, it has no authentication, no encryption, anything can connect to my Raspberry Pi and the Mosquito server that's running on it right now and send and receive messages. And for this video, I think we're going to live with that, and we're just going to keep it simple and keep it all unencrypted and no authentication. But just something to be aware of, that you probably want to look at the Mosquito server configuration, and there are lots of ways to configure it. You can set up like users with a username and password that can be allowed to access certain topics. You can set up encryption using like certificates, and it gets a little more advanced about how to generate those things. But just be aware that by default it kind of runs and it's open by default. And I don't know if it's going to be like that in the future, because a lot of things start out that way and then we realize, oh wait, this is a massive security hole. So just something to be aware of in the future if you're using Mosquito, that maybe it won't be open in the future. But for now we're living with this default config to make it secure. So okay, so Mosquito's here and it's running. Now to start using it, so there are a few things we can do. So on the Pi, we can actually, and here, let me go back to my home directory. There are a couple command line tools we can use to just demonstrate like some of these basic concepts of a topic that you can publish and subscribe to. So there's a mosquito_pub tool and a mosquito_sub tool and each of those, one of those is for publishing a message and the other is for subscribing to a topic and receiving messages there. And I think by default it installs it, but let me just check. So if I run like mosquito pub, okay, command not found. So you actually need to do apt-get install, I believe it's mosquito tools, I want to say. Let's see if this is it. If not, okay, let's apt-cache search mosquito. And this should show us the tool. Oh, mosquito-clients is what we want. So let's install this, and this will give us the command line tools on the Raspberry Pi. So let's do sudo apt-get install mosquito-clients. Oops, I misspelled that. Clients. There we go. So this will install the little command line tools. And then while it's doing that, I'm actually on my Mac. So this is not the Raspberry Pi. This is just my Mac OS X computer. I have the Mosquito command line tools also installed here, and I did that with Homebrew. If you do brew install Mosquito, this installs the Mosquito MQTT server and it installs these command line tools. Now luckily the Mosquito server doesn't run by default with Homebrew, so you don't need to worry about like it exposing a server that you might not expect. But that's how I did it. And for other platforms, go to the Mosquito webpage and they have this download section. And you can download like pre-built binaries. Like Windows, you probably need this Win32.exe that you want to run, and they've got everything else kind of listed here. So that's pretty surprising. Like, I mean, they've got OpenWRT, so if you've got a little router that you're running some code on, or even the Arduino Yun, that uses a version of OpenWRT. So you could run the Mosquito clients and server on there too. So they've got everything you need, but make sure to get these client tools. And you don't have to have them. It's just they're handy to have for debugging things and actually testing the server. So okay, so on the Raspberry Pi. So I installed those Mosquito client tools, and you want to now let's subscribe to a topic. So I'll show you kind of both publishing and subscribing. And first, let's just subscribe. So the way the tool works, it's mosquito underscore sub is the tool. And so if you run this, you basically need to tell it, what server and what topic to subscribe to. And I think they have a few more details. Yeah, here we go. If you do the -- help option, this tells you a little bit more. So you can say this -h is the host that you want to connect to. That's the MQTT server that you want to connect to. There are a lot of other options here. We're going to pick most of the defaults. The one that is interesting though is the -t option here, where you specify the topic that you want to subscribe to. And so this is just a string. And so let's just try this. Let's do mosquito sub -h, so the host, and it's just localhost that I want to use here. So that's the Raspberry Pi itself, because I'm running this command on the Pi, and the Pi is also running the MQTT server. So I just tell it, connect to localhost. And then the topic I want to subscribe to, let's just say /foo. And this could be anything. Like it could just be foo. You don't have to have a slash. There is kind of a convention in MQTT that you create like a tree or a hierarchy. So you can have like /foo, /bar, /baz, and then maybe like you have a foo bar, Bing or something in here. So, whatever you want. You can have, you could even imagine these are devices. So like maybe this is like /home, /kitchen, /light, something like that. And then maybe inside of there I also have like a switch, or maybe my IoT blender or something like that. So it's really up to you to define this hierarchy of topics and make it as simple or as complex as you want. But just for now, let's do the /foo topic. Now this is just going to sit here. It's not going to really look like it's done anything, but it's actually connected to the MQTT server, and it told the server, hey, I'm subscribed to topic /foo. When anything happens, tell me about it. If something happens to that topic, like if someone publishes a message, give me that message so I can deal with that message. So let's look at now, I'm going to go from my Mac now, my Macintosh computer that I'm actually streaming from here, and let's publish a message to that foo topic. So we're going to use the mosquito _ pub command, and this is very similar to sub. Oops, I'll do the help here. And this again takes same kind of command line parameters. So you give it the host that you want to connect to, that's your MQTT server. So in this case, I need to tell it about my Raspberry Pi. You can then give it the topic that you want to publish on, and then you can also give it a message in here. And so I'm going to give both those options. So let's do that. Let's do mosquito publish -h. Now I need to tell it my Raspberry Pi. I'm going to give it the host name, just because on my network, my router runs a little DNS server that knows that my Raspberry Pi has this host name. It can convert to the IP address. And then I'm going to give it the topic, so I want to publish on /foo. And then the message with -m will just say, hello world. And oops, let's see, what did I do wrong? Oh, this always trips me up. Let me go back. Basically, when you use an exclamation quote in double, or an exclamation mark in double quotes, Bash tries to interpret that, so you need to use single quotes. So mosquito pub -h Raspberry Pi -t single quote /foo. Even though I'm not using exclamation, it's good to get in that habit. Single quote, hello world. There we go. So, and this doesn't look like it really did anything, but let's go back to our Raspberry Pi and look at that. We received our hello world message. So, let's do it again, and maybe I can pull this out so we see kind of both these at once. So let's just do mosquito pub hello world 2. And so it just sent the message, and there you see it. It showed up. It received it pretty quickly there. So, pretty simple, pretty straightforward. It's just publishing and subscribing to different messages. And just to show, like, I can publish on other topics. Like, let's do /foo /bar. And so we just sent hello world 2 to that. And notice we don't see anything showing up here because this is only subscribed to this /foo topic. And I can actually close this. And you might think like, okay, well, what if I subscribe to foo bar right now? Notice I don't get that message that was earlier sent. So by default, it's not really set up to, be like guaranteeing the delivery of this message. But you could actually configure things so that the MQTT server could remember that message and send it back to a new client. But we're not going to get into that. But it's just something to be aware of. There's some cool advanced things that you can do with this. Okay, so that's kind of the basics. I mean, I've got the MQTT server running on my Pi. It's kind of the main broker. It has a concept of all these topics. And so I was thinking like, okay, let's create a topic. One topic could be /LEDs /ESP8266, and that could be the LED state of the little ESP8266 board that we have right here. And another topic could be the /LED/Pi, and so that would be the LED on the Raspberry Pi. And then anything could connect and send a message like on or off or toggle to one of those topics, and then we'll have code that's running on both these to listen to those and toggle the LED state, change things whenever it receives that message here. So let's kind of start with, I was thinking, let's start with the ESP side first. And so we'll write some code that listens to the button press, it connects to the MQTT broker on the Pi, and then sends it a message on the little Pi LED topic, and then it'll also listen for the ESP8266 topic on its LED, and then when it receives a message there, it can toggle the LED. So let's kind of dive in here and get kind of started. Let's see, I'll close this out so we don't need that. And let's see, I'll cancel out on the Pi right here. So on the Pi, let's see, we'll come back to the Pi. So let's start with the code, and this is a link to the GitHub repository that has all the code for this series of videos. And I'll start from the part 3 code, and we'll kind of morph it into the code that we want to write here. We'll see that some stuff is simpler, and then we need to add some extra stuff for it. So in the Arduino IDE, now there's a little bit of setup that we need to do. So in the last example, we were just using some raw socket code that's already in the ESP8266 libraries, so we didn't need to install anything special. For this code, we're going to use a library. We're going to use the Adafruit MQTT Arduino library. So let me just give a link to that, Adafruit MQTT. And this is a nice little library that we wrote mostly to talk to Adafruit I/O, but it's basically a library that can talk the MQTT protocol, and it works with the ESP8266, FONA, CC3000, generic Arduino Ethernet classes, so it lets you do basic publish and subscribe to MQTT server topics from here. So we're going to use this library to talk to our MQTT server on the Pi. Now to use this library, we need to install a few things. So if you go into the Sketch, the Include library, the Manage libraries, this brings up Arduino's library manager. And you want to install, so if you search for MQTT, you'll find here's the MQTT, Adafruit MQTT library. It looks like there are lots of other MQTT libraries, which you could probably use because this is a standard protocol. We're not using anything special or custom here, so definitely check out other libraries if you're curious about them. But install this one, and then it also depends on this little library called Sleepy Dog, which is basically a watchdog library. And it was used in like the CC3000 and the FONA code. We would usually use the watchdog to make it a little more reliable. And unfortunately, just because the library uses this, even though we don't use it in the ESP code, you have to install it. So install both the Sleepy Dog and the MQTT libraries, and then you're good to go to use this library. And once you have those installed, let's open up an example from it. So we'll open up the MQTT library, and let's do the MQTT underscore ESP8266 example right here. And so we'll load this up, and we'll kind of start with this as our base, and then go from here to customize it in different ways. So I'll close that unused sketch there. And okay, so there's a little bit of configuration we need to do for this sketch. So it needs to connect to my Wi-Fi network, which everyone's seen in every video now, so it's not the biggest secret in the world, but I'll put in my Wi-Fi password. Oops, that's the wrong TDI colon. There we go. And then now this sketch is more set up to talk to Adafruit I/O, which runs an MQTT server, so you can publish and subscribe to messages there. But we're running our own MQTT server, so I'm going to kind of tweak the sketch a little bit here. Like it's a little bit Adafruit I/O specific at the top here, where you need like your username and password here. So let's just kind of delete a lot of this stuff, or maybe let's change this. So let's make this define a little more generic. So it's MQTT server. Let's do MQTT port. And then we do actually need an MQTT username and an MQTT password we'll put in here. And so, okay, so for the values of these, now my MQTT server, so this needs to be the Raspberry Pi. And like you've seen in the previous videos, I think the easiest way to get this set up is to give your Raspberry Pi a static IP address. So if I go back to my Pi, if I run the ifconfig command, you can see my Pi has 192.168.1.42, and that's a static IP that I've set ahead of time. Go back to the very first video on this series, and I actually show how to set up a static IP on a Raspberry Pi like this. It's the easiest option, I think, to make this work, because basically the ESP board needs to connect to the Raspberry Pi, and so by giving this IP, it's just a direct way to say here's where the Pi lives. And since I gave the Pi a static IP address, it's always going to have that IP. It's never going to get some random value. So okay, so we'll give it the IP. The port, keep this the default, 1883. That's kind of the standard port for the unencrypted version of MQTT, which is what we're going to use. But there is an encrypted version, and I'm not going to use it in this example, but that uses a different port here. Now for the username, we're actually going to set this to just an empty string, just double quote, double quote. And same thing for the password. And that's because our MQTT server doesn't have any username or password authentication that it's using right now. So just set these to empty strings. And you have to have an empty string, unfortunately. It's just the way the library is set up here. But okay, so now let's kind of go through the rest of the code. So it creates a Wi-Fi client. That's the ESP's basic kind of like Wi-Fi connection class. You can also make a secure client, which is kind of how you can connect to an SSL service, but we're not going to use that. So we'll just delete this. Now the code right now, it does some weird stuff here in that it takes the variables that we set as defines and creates these constchar progmem variables. This is more for the AVR code, where it wants to store this in the flash memory of the AVR. On the ESP, it has a lot more flash memories, and if you actually just create a constchar string, that gets stored in flash on the ESP. So bottom line, we don't need this code because we're running on the ESP. It's just, it's a nice thing to have, but it's not necessary. So we'll delete that. Now this next line, this actually creates an MQTT client object, and that's what we need to publish and subscribe to different topics. And so it takes in a reference to a Wi-Fi client class, which is the ESP Wi-Fi class, and then it also takes in the MQTT server that we set up here. It takes in the port, which we renamed, so let's fix this up, MQTT_port. And then the username and the password, which we set up here as just empty strings. So those are just going to say, hey, don't use any username and password here. So okay, so that's cool. So that's the setup we need to initialize the MQTT library. And then the next thing is we set up the feeds that we want to subscribe and publish to. So for both publishing to a topic and subscribing to a topic, you need to create a special object here. For publishing, there's an Adafruit MQTT publish object, and for subscribing, there's an MQTT subscribe object that we need to create. And in this example, it's kind of set up to publish to a photocell feed and subscribe to an on-off button. But we're going to change this a little bit. And let's see, I'm actually going to simplify the code a little bit. So again, this is doing that progmem thing just because on AVR boards, you want to make sure this stuff goes into flash memory versus this ESP board. It's a little bit easier. You don't need to worry about that. Like just a constant string by default is going to be in flash. So I'm just going to delete this. And then, so let's do a publish. And instead of calling this photocell, let's call this Pi LED, because we're going to want to publish on a topic that controls the LED on the Raspberry Pi. And then the parameters that you pass this object when you create it, you need to give it a reference to your MQTT client that you created above. And then you also need to give it a string that's the path that you want to publish against. And so let's do /LEDs/Pi. So you can kind of see, like I'm thinking, let's make a simple hierarchy where there's a /LEDs hierarchy, and then all my LEDs are inside of there. So I have like a /Pi LED. And then for the ESP board itself, I can have /LEDs/ESP8266. So let's do the exact same thing then for our subscribe object down here. So let's make this the ESP8266 LED because this is, it's going to listen for changes on its LED right there. And let's make this the topic. The path should be /LEDs/ESP8266. So okay, so that's pretty simple and straightforward. So now I've created both those objects. Now the rest of this sketch we'll kind of go through. Like the setup is all like your basic setup. Connect to your Wi-Fi network, and then after you've connected, for all the feeds that you want to subscribe to, you need to call this subscribe function and pass it a reference to that feed. So I'm subscribing to my ESP8266 LED feed, so I want to pass a reference there. This just tells the library that, hey, I've got some feed that I want to listen to subscriptions against, and it'll kind of keep a reference to that so that it knows what to do. And then inside of here, in the main loop, it starts out by calling this MQTT connect function, which is defined at the bottom. And basically all that this function does is it looks to see, is the ESP board connected to the MQTT server on the Raspberry Pi? If it's not connected, go and try and connect, and it'll make a few connection attempts. And so it's kind of nice. It's smart to put this at the top of the loop, because basically this means that every time the loop runs, it's going to check and see, is it connected? And if it's not connected for some reason, it's going to reconnect and try and get connected back to the server, because you can be disconnected from the MQTT server. Like there could be like a network issue, maybe your Wi-Fi network goes down and you get disconnected, and so this is going to constantly keep retrying so that eventually when your network comes back, it'll connect. But your MQTT server itself might have like a time limit. It could have a 60-second time limit where it says, okay, if you're subscribed to some topic, or if you're connected to me and you haven't sent me any kind of a notification that you're still alive, if you connected to the server and then did nothing, at some point the server is going to say, look, I don't know if you're still connected or not, I'm just going to disconnect you. So they have like a concept of a keep alive. And so that can happen where you get disconnected periodically if you aren't sending or receiving any data. So it's smart to have this concept of looking to see, are you connected, and then reconnecting if you're not connected already. And the nice thing is, we've kind of just put that into a function that you don't need to worry about. And so just as long as I call this every time I do a loop iteration, it should make sure that I'm always connected to this server. Now the next part of the code is it goes through, and this is the block where it reads the subscriptions, any of the subscribed topics. It looks for new messages that it receives. So it calls this read subscription function on the MQTT client object, and it actually gives it a timeout. So this is actually passing 5,000 milliseconds as a timeout. And so that's basically saying, okay, wait up to 5 seconds to receive data on any of the subscribed topics. And if it does receive data, then it's going to return a reference to the topic that it received data on. So in our case, we've renamed it, so it's the ESP8266 LED topic. Now one thing, I'm going to actually change this. I'm going to remove this 5,000 because I have other stuff that I want to do in this main loop. I want to listen for button presses. And so if I had a 5-second timeout, it's going to slow things down a lot, because when it gets to this read subscription, it's going to wait up to 5 seconds to receive a message. And during that time I might be jamming on the button, trying to press it, and nothing's going to happen because it's just waiting for that topic to be received. So if you remove that 5,000, then it's not going to spend any time. It has no timeout. It's just going to do a quick check to see, did I receive a message? And if you didn't receive a message, it's going to very quickly go on to the next bit of code there. So just a smart thing to think about, that be aware of the timeouts and things that different functions have. So okay, so when it does receive a message on a topic, it returns a reference to that topic, and it's in this while loop, which might seem a little weird, just because it's basically saying, okay, keep calling read subscription as long as it's getting something back. As long as read subscription returns back a reference to one of these Adafruit MQTT subscribe objects, then keep calling it. So it's like a loop where it just processes any subscriptions that have been received, and as soon as it hasn't received any data from any subscription, it returns null back. And then the way that the C code kind of works, or C++ code, it's going to look and see, okay, what was subscription set to, and if it's set to null, that evaluates to false, and it breaks out of this while loop here. So this just means, call read subscription until you get nothing back. So it'll just very quickly do a quick check of anything that we've subscribed to. Now we've only subscribed to one topic, but you could subscribe to other topics and receive data on them here. So that's what's happening there. And then inside the loop, so while this is not null, while I've received some subscription value back, I just do a quick check to see, is the subscription that I received the ESP LED subscription? And then it just prints out, for now, it says, okay, it prints out this .last read attribute on the subscribe object. And so that's a string that has the payload of the message that was received. And just one thing to be aware of, by default, the MQTT library, it can only receive payloads of up to 20 bytes long. You can increase that. There's a define in the header for it. But that's okay for us because we're just sending simple messages like on, off, toggle. But just something to be aware of, that it's not, you can't just send like giant chunks of text because, again, this little ESP board, it's got to load it into memory and it only has a few kilobytes of memory. So, okay, so let's just keep this, but I need to make sure that I rename this because I renamed my subscribe topic. So let's keep this code as is. So, anytime it receives a message on this /LED/ESP8266, it should receive it and print it out right here in this bit of code. So that's cool. Now the next bit of code in this example, it will actually publish a value against this photo cell. The only interesting thing here is to see this .publish function. So you can basically call this and pass in like a string or a number, and it'll publish against the topic that we've defined. So let's come back to this. We'll add our button logic, but maybe first let's just see that we can read and receive messages on our ESP board. So and then the very last thing, this says you can ping the server if you uncomment this. So there's a ping function. And this comes back to that keep alive where I said, when a client connects to an MQTT server, usually that server has like a minimum amount of time, or a maximum amount of time rather, that it'll wait for that client to do something. And that something could be publish a message, or it could be send a little ping. And so that just tells the MQTT server that, hey, I'm still alive, my code is still running, I haven't locked up, I haven't crashed, which is smart for a lot of network programming. When you have something connected to you, that's taking some resources. Like there's a little bit of CPU load you need to worry about, like checking that connection periodically. So the servers don't want to have a lot of like zombie connections where some client connected and then who knows if it's still there. So that's why things can get disconnected periodically. I'm just going to delete this though because, like I said, at the very top of the loop, we have this MQTT connect function up here, so that if I do happen to get disconnected because, I haven't sent or received any data in a long time, it's just going to catch that and reconnect automatically. So, a couple of different ways to approach the problem. I think it's, we'll keep it simpler in this example and just use this MQTT connect code here. So I think we're all set up. Let me just double check and make sure I've got everything configured. So my Wi-Fi network and then the IP address of the Pi. So yeah, everything looks good there. So let's make sure it compiles, and then let's load it up on the ESP board. And then we should be able to see if I send a message on the /LEDs/ESP8266 topic, it should print it out in the serial monitor. So let's just see real quickly if this works. And so it's just compiling the code. So it's going to run GCC, and okay, so it compiles. So let's upload it. Let me make sure I've got the board selected. So yep, my ESP board, and it's got the right port, so that looks all good. So let's press upload, and we'll write to our ESP board here. And then while this is happening, we can look real quick. And so let's go from my Mac computer again. So I'll send the message from my Mac to the Raspberry Pi, the MQTT server on here. And I'm going to send a message on that /LED/ESP8266 path. And then we should hopefully see from the serial output of the ESP8266 that it receives that message. So let's open up the serial monitor. And so we don't see anything right now because it's already connected to my network. But I'll just reset the ESP board just to make sure that we see the output there. So you can kind of see there's a bunch of junk as it's resetting. And then after a second here, it should reconnect to the server, to the Wi-Fi network rather. So give it a second. I think its bootloader is probably running right now. And then we should see that it prints out in a moment here. Although just kind of waiting here. Wow, I don't know what Arduino is doing. Let's let's close this. Looks like the Arduino IDE is kind of locked up here. I don't know why. Maybe it's receiving too much serial data that it doesn't like. So okay, well, let's try this again. Let's open the serial monitor. Wow, that is weird. So I pressed the reset, and for some reason my ESP board is freaking out. Let's just disconnect the ESP board and see. I don't like when I see all this serial output in here. So okay, let's reconnect the board, and now let's see. And you'll notice the LED turned on. That's just because I'm not using the LED, and so by default, in this sketch, it's just happens to turn it on. So okay, let's make sure I've got, yep, there's the board. Let's open the serial monitor now. And okay, wow, that is really bizarre why it's spamming a bunch of, oh, I know why. I probably don't have my baud rate set correctly. So let's scroll down. Well, let's close this first because it's interesting. It's causing a lot of CPU load. So okay, let's go back. So I do have the baud rate set correctly. So that's a little weird why it failed there. Oh, it's still uploading. Okay, so word the why. So I pressed upload and I opened the serial monitor as it was still uploading. So we were kind of seeing like it was sending the data, and then I just disconnected it. So okay, let's start over here. Okay, so I've got it connected. Let's click upload now, and let's let it finish uploading before I start opening the serial monitor and monkeying around with the data here. So okay, and I forgot because unfortunately the ESP board, it takes a little bit of time. It's programming. I think it's like 4 megabits of flash memory, which is way more than a normal Arduino has, and it's doing it over serial connection, so it takes a little bit of time. So it's something to watch out for. So you can see I turned on the verbose output in the Arduino IDE. It's under the preferences here, which I think it's kind of handy because in most cases when something goes wrong in Arduino, it's usually when you're uploading the code. And so I like to have that verbose output so I can see like it's telling me here's exactly the commands that it ran when it wanted to upload. And so okay, now, and it prints out those dots as it's uploading. So okay, now we're done uploading. Now let's open the serial monitor, and we should be okay here. So I'm not going to touch anything. Let's just try. Let's publish our message. So let's assume we've connected. Let's just go for broke here and make sure that it works. So okay, let's put the serial monitor down here, and then on my Mac, let's just kind of scroll this up. So remember, I'm connected to my Mac. I'm going to publish a topic, mosquito_pub. The host name is my Raspberry Pi. Oops, Raspberry Pi. And then the topic, I want to do /LEDs/ESP8266. And then the message, let's just say hello. I'm going to remember bash doesn't like exclamations. So let's do that. And look at that. We just printed out, we got the hello message. And, let's say, like, what if we sent on to this? There's on or there's off. So that's cool. Basically my ESP board is connected to my Raspberry Pi MQTT server. And it received a message that my Mac computer sent to the Raspberry Pi, and then the Pi saw that, oh, this message is for my ESP board because it's subscribed to that topic, and so it sent that message to the ESP board. So it's pretty cool, and that my Mac doesn't know about my ESP board, doesn't know how to connect to it, but it can still send data to it because it's using that Raspberry Pi MQTT server as a kind of intermediary, as a broker that sends those messages around. So okay, cool. Now let's add the LED. Let's start getting some fun stuff in here. So at the top, let's copy out a few things from the old example, from the part 3 example. So I'm going to grab the code that we had there, and we'll grab a few things out of here. So like let's grab the defines for the LED pin and the button pin, and so we'll put these inside of here. And these just define, so my LED is connected to pin 2 on the ESP board, and then the button is connected to pin 15. And in the setup, I need to do the exact same setup for those inputs and outputs, so I'm just going to copy that code out here. So set up my LED as an output and my button pin as an input with a pull-up resistor, so that way, because the button's only connected to ground, so I need that pull-up so I can detect when it's pressed, exactly like we did in the last video. So let's have that code in there. And now I'm ready to look at the subscription data in here. So let's look at, once in this part of the loop, I'm reading the subscription data. I'm printing out when I receive the data. I'm just going to change things a little bit. Let's make a variable to hold the message we received. So we'll call message, and let's just say ESP8266_LED.lastRead. This will just simplify things a little bit so that we can use this message, because basically this last read is a unsigned 8-bit integer buffer, which it's the same size as a character, but you have to do a lot of these type conversions in C. And so I figured let's just do it in one place. So we'll do it up here, and now I can just print out the message that I received here. So we'll say message. And now let's actually look at the contents of this message. And just like we did in the last examples, we can use the string compare function. So we'll say if strncmp, and let's compare message to on. So if someone sends an on message, let's have it turn that LED on. And I'm using the N version, so this limits it to up, to some number of characters. And my on message is only 2 characters long, so I'm just giving the length there. And if that equals 0, then they're a match. They're equal. So in this case, then I want to turn my LED on. So let's say digital write LED pin high. And let's do an else if clause. So let's check for the message that says off. And this one's 3 characters long. And so if we get that, then let's digital write the LED pin off, so low level. So that'll turn the LED on and off. And then let's also add a third command in here. Let's put a toggle command in. So else if we get strncmp message toggle. And this one is, let's see, 1, 2, 3, 4, 5, 6 characters long. So if that equals 0, and then let's do that little toggle that I did before in the last video. So toggle the LED, so you do digital write, and you invert a digital read on the same pin. So oops, digital read LED pin. So this is going to basically read what's the current level of the LED, if it's a high level or low level, and then the exclamation is the Boolean invert or not, and that's just going to swap it. So if it's at a high level, it goes down to a low level, and vice versa. So that should be good enough. Let's just make sure that compiles, and then let's upload it, and then we should be able to see now if I send on, off, or toggle, it should change the state of the LED. And I can do that again from my Macintosh computer. So let's just wait for this to finish compiling. And unfortunately, it's the one annoying thing is it's sometimes a little bit slow to compile on the Arduino IDE. So you just sometimes have to put up with because behind the scenes, this has to run a special cross compiler. It's a version of GCC that's built for this Extensa architecture that the ESP board supports. So you can't just use like a normal compiler that you might have installed already. It's got to emit the right code for the platform. So okay, so we're doing the upload, and it's going to go upload to the board. So it's writing the board. I'll be careful this time. I'm not going to open up the serial monitor and start messing with the chip. But luckily, it doesn't take too long for this thing to upload. So doing the upload thing right now. And I think you might be able to speed it up a little bit. I think you can use a different baud rate, but I haven't played much with it when you write to the ESP board. That might help a little bit to increase it. So, okay, so we're done. And now we see here's the serial output, and okay, good. And you can see here's the serial output that is in the setup function, which just says that we connected and everything's good. So, okay, cool. Let's try this now. Let's send on. And we're going to send it to the same topic, that LEDs ESP8266. And now when I do that, hey, look at that, LED turned on. And we do off, turns it off. And then let's try our toggle. So we sent toggle, you see it turns it on. And then if I do toggle again, turns it off. And you can see we're receiving everything. And then just to show, like, let's just send, like a foo or a foo message on here. And you can see that doesn't do anything. Like we print it out at least. We see we received it, but nothing actually happens here. So okay, cool. We're pretty close here. We've got we can receive a message. Now let's do the sending part from the ESP. So let's have it so when I press this button, it sends a message to the broker that says, now under that /LEDs/pi path, let's have it send like a toggle command that turns the LED on and off. And I'll show you, it's not super complex. It's actually pretty straightforward to do this. So, like you saw above, we created, so there's the MQTT subscribe object, which we've just used to listen to that ESP8266 path. Now let's use this publish object, which is going to publish messages against that /LEDs/pi path. And so to use this, first I want to pull in the logic from the previous example where I check for a button press. So let's do that at the top of my loop here. And let's see, so we'll put in this logic right here. Oops. And so we're going to check for the button press. And like you saw in the previous video, the way I'm checking for button press is I take an initial reading, I wait 20 milliseconds, I take a second reading, and so if during that 20 millisecond delay, if the button was pressed, it's going to change its level, and I look for when it was at a high level falling down to a low level, which means I just pressed the button. It's like that transition from high to low. And if that happens, then we say, okay, you press the button. Now our old code was using, like a direct connection to the Raspberry Pi to send it a command over a socket. But let's pull that out. We're not going to use that just yet. let's actually put in our code to publish a message on the topic that we've created already. So we have the pi underscore LED object. So that's just that publish object that we saw above here. And it has a publish function that we can call on it. So if I just do .publish, and I can publish pretty much anything. I can publish a string, a number, and so let's just publish a string, and let's publish toggle. So this will just say, okay, you know, tell the pi LED to turn on or off, depending what state it's in right now. So let's save this. Now, one thing I'm going to do, because I did this ahead of time and kind of saw some issues, so, and it might not be super obvious, this, you know, the problem. Like I could run this as is, but you might notice the button would be a little bit flaky. And that's because the way I'm detecting button presses, I'm relying on the fact that everything in my main loop is really fast. And so most of the time it's going to be stuck in this delay for 20 milliseconds, you know, waiting for that button to change state. And that was true in our last, you know, part 3 example, but in this example, things are a little more complex. So like in my main loop, I'm calling this connect function, and this might take some time. Like it, you know, it needs to check, is it connected to the MQTT server? And if it's not, like go and connect to the server. And I think there's like up to a 5-second timeout that it can wait. And then I have this like bit of code here that's checking for new topics or new subscriptions that have received data. And, you know, it takes a little bit of time to receive that. So, you know, what happens if during this time I press the button and, you know, it changes state? Well, my code up here is going to miss that because it ran for a little while. It waited to see if it saw that button press change state, didn't see anything, and then the code went on to run this bit, you know, in the loop. And then if my button press happened here, it's completely missed by the logic above here. So I think the easiest way to do this is actually to split it out, and let's take that initial button press at the very start of my loop, run the rest of my code here, and then let's put the rest of my logic down here. So, you know, I'll still do that 20 millisecond delay, but then I take my second reading. And so this should be a lot more reliable because now I say, okay, start of my loop, let's take an initial read, and then if at any point during this loop I press this button and, you know, keep it held down until this second reading, then it's going to detect it no matter what. And so it just makes it a little more stable, a little more reliable. I didn't have this initially, and I noticed like every now and then I would press it and you would get nothing. And so it's, you know, just something to be aware of, that when you're relying on detecting button presses like this, you know, you have to be very careful about how long your code you know, takes to run. And there are other ways to detect button presses. Like you could actually connect this to a pin that supports interrupts. And I don't know if the ESP board has a lot of external interrupts, but you know, on an Arduino you can have a pin that if it changes level from high to low, it can actually like interrupt your code and run some interrupt handler, and you could put some logic in there to say, hey, the button's been pressed. So that's, you know, that's usually how you want to detect things without having to have all this complex logic like that. But it's, you know, something to be aware of. But this should work. This will be fine for us. So, okay, so let's make sure this compiles, and then let's upload this. And while we wait for this, on my Mac, I'm going to use the mosquito pub command. So let's do mosquito sub. So let's subscribe to a topic, and I'm going to, you know, point at the Raspberry Pi. And let's subscribe to the /LEDs/pi topic. So now my Mac is going to listen for anything that's published against that topic. And now let's upload our sketch to the ESP board, and then we should see that hopefully this, when I press the button, we should toggle, or we should see that a toggle message is sent. So we'll give this a second. This is going to do its compile thing again, and then it's going to upload to the board. It almost feels like I need like a music or, you know, theme song, like the waiting to upload to board song while this goes. So, okay, so we're uploading. So it's sending all the flash data, and in just a second here it should run, and then we'll see in the serial output also once it connects to the Wi-Fi network. So it's doing its thing. Come on, finish up, and then let's see. So I'll move this up here so we can kind of see both these at once. So, okay, there we go. So it's connected and it's running, and up here I'm subscribed to this LEDs/pi topic. So let's press the button, and hey, look at that. So you can see, you know, our sketch detected the button was pressed, and then notice we received that toggle command that was sent, you know, using that publish function right here. So, you know, let's just see, as I press this, you know, I can really press the button a bunch of times, And every time you see a toggle message, and you can see it's pretty quick. Like as soon as I press that button, you know, boom, there's a little toggle message. And that's just because the MQTT protocol, it's very lightweight, doesn't have a lot of overhead of like, you know, handshaking messages and like verifying all this stuff. It's just blasting bits out. And it's a little more advanced than just blasting raw bytes of data, but it is nice in that it's very quick. So, okay, cool. So I think the ESP side is complete. Like we can see it's sending messages on the topic that we want, and it's receiving messages. Like, you know, so it's, our code is still running. If I go and if I run that, you know, toggle command, it's toggling the LED on here when I publish to that topic. So, okay, cool. So we're halfway there. We've got the ESP side. Now let's go to our Raspberry Pi, and I'll show you we can, because now all we need is a little Python script that runs, and it listens to that /LED/pi path, and when it sees the toggle message on there, it changes the LED, and then also listen to our button press. So when we receive a button press, you know, go in and send a message to the ESP LED here. So let's kind of start with the code from our previous example. So in our previous example, we had this little server code that we ran, and so let's open up in our code here. So I've got a copy of it here, the server.py. And now remember, you know, the last video we used these raw socket servers. This time around, we're going to actually just use an MQTT library that can actually talk to our MQTT server. And you'll see the code is a lot simpler. So I think, you know, nice advantage here in that, you know, again, in this video, I'm really kind of showing that by using an existing protocol and server, it simplifies our code, and you get a lot more features and things. So that, you know, and it's good. I think it's cool that we showed in the previous video how to do it using these raw sockets, because there are definitely times when you need to get down to that low level and do your own protocol. But in most cases, you probably want to build on an existing protocol like this. So, okay, let's take our existing example. And before I use this, we need to install a library on the Raspberry Pi. And actually, I'm going to go into the directory where I have this code. So let's go into the Raspberry Pi, the part 4 stream, and let's go into our Python 3 server directory. So there's a library that we need to install, and it's the Paho-MQTT library for Python. And so Paho is a part of the Eclipse project, and it's a MQTT library. I think the Mosquito server is actually part of the Paho project also. But it basically has all these reference implementations of MQTT clients. And they have a great Python client here. And it's really easy to install and use. So we can use the pip package manager to install this. And because I'm using Python 3, remember you need to use sudo pip3 to install this for Python 3. But this can also work with Python 2. So you know you can use either version. So do sudo pip3 install Paho-MQTT. And this will install it globally. I've already got installed, so it's, you know, no big deal. And then to use it, and you know, again, I'll put links below in the description to this page right here. This is the Python package index page. They kind of give you a quick start that that we're just going to use directly here. So it shows how to use this. Basically, you create callback functions like an onConnect and an onMessage, and these will be called whenever some event happens, like a message was received on an MQTT topic, or you connected to the MQTT server. And then you create this little client object, and you connect to your server, and then you just kind of let it run its own little loop. Kind of like we saw in our Python socket server code. You know, remember we had to tell it to run our server.serveForever in a little background thread. But the nice thing is we'll see that the Paho library has a lot of this logic already. Like it can create a background thread, so we don't even have to worry about doing that ourselves. So I'm actually going to rip out all of these defines. I don't need any of these anymore. And then let's just start building off their example. So let's import the library like they mentioned right here. So we import the Paho.MQTT client. I'm going to keep most of the config, although I don't need this config anymore. I don't need the address, the port, and the name of my device, because remember my my Python code doesn't connect directly to the ESP anymore. It just connects to the little MQTT server. So I don't need to know or care about the name of my, or the IP address of my ESP8266. So hey, that's gone. That's simple. And then the server port and address, I don't need that either because I'm using MQTT and it's already got its own port and address, you know, the protocol that defines all that stuff. So let's rip that out. Let's rip out this whole server handler stuff. I don't need that. That's for the socket server that we're not using anymore. But let's pull in some of the code that they have here. So let's grab their onConnect and their onMessage callbacks. So these are just functions that will be called when certain events happen. And I'm just going to keep them as is for now. You can kind of see, so the onConnect callback, it just prints out, hey, I connected. And then it calls this client.subscribe. So just like you saw in the ESP code, you need to subscribe to a topic that you want to publish or receive messages on. And so here, let's have it subscribe to the /LEDs /Pi topic. So it'll listen for Raspberry Pi LED notifications here. And if I didn't do this, my code would never actually receive these messages. Like the library needs to be told, I want to listen to this topic. So you won't just receive every message by default. You only receive messages that you subscribe to for this. And then on message, this is actually what's going to be called when it receives a message. So let's just keep the default here. We're basically just going to print the topic and then the payload that it received for that. So okay, so that's good. Then we need to grab the code right here that actually creates this little client object, and it sets up these callbacks. So it defines, my onConnect callback is my onConnect function that I defined up here, and you can rename those. You can make those whatever you wanted. Same thing for onMessage. And there are other events, like I think there's a disconnect event, all kinds of things that you can look at, but we're keeping this simple. Now the connect function, this needs to take in the server to connect to, and because this is going to run on the Raspberry Pi that's also hosting the MQTT server, I'm just going to use localhost. That just says connect to yourself. This takes in the port, which is 1883. That's the default MQTT port, and that the Mosquito is set up to listen on. And then the third parameter is the keep alive period, where basically this says how many seconds should it wait before sending a little ping message. So just like the ESP code where I was kind of mentioning, you need to worry about if you connect and you don't do anything for a while, your client might get disconnected. So for the Paho client, you can tell it, okay, every 60 seconds, if you haven't done anything, send a little ping to the server to just say, hey, I'm still here, I'm alive, don't disconnect me. So we'll keep the default here. I think that's fine. So okay, so that's good. Now they go in and they do this loop forever. So let's do that. Let's put a loop forever in here, and we'll just comment out our code. And this is kind of like we saw in the previous video. This loop forever is going to block. It's never going to return. It's going to run a loop, and it's going to wait, and once it connects to the server, it's going to run my little onConnect here, and that's going to subscribe to my LED topic. And then once it receives a message on that topic, it's going to run this little code here. So let's just save this and let's run our server on the Pi. So we'll say sudo python3, and this is the server.py. Let me just make sure I have the file name right. Yep, the server.py. So okay, so now we're running it, and you can see that it just connected. So we received our connected with result code 0 message, and that's just our onConnect function was called here. So, and RC0 just means like it's good. There wasn't an error. If there was an error, this RC would be a different value. And they actually say, I think in the description for the Paho library, like which ones you might get. But okay, so now in theory, we're subscribed to the LEDs Pi topic. So let's press the button and look at this. So I'm pressing the button on the ESP board. That's sending a message to the LEDs Pi topic. And you can see we're receiving the message. It's the byte string toggle, which is perfect. That's exactly what we wanted to receive. So cool, we're receiving our message. So let's start adding some code here to handle this message. So I'm going to copy out. Let's grab our GPIO initialization code, and let's put this code. Let's put this at the very start, at the top, and let's uncomment this and kind of fix the indentation. So there we go. So this is just going to set up the LED as an output, turn it off by default, and then set up the button as an input. Now in my message handler, so you can see we're just printing out the message right now, but let's actually look at our topic. So let's see if the message.topic equals /LEDs/Pi, then I know that I've received some message on that topic. And then let's look at the contents of that. So if my message.payload equals the byte string toggle, and again, because this is Python 3 and strings are Unicode by default, whereas this payload happens to just be a string of bytes. So I want to actually use a byte string here. And it is important. If I didn't have this B, it wouldn't work. It wouldn't catch this. But luckily, you can kind of see, like, because I'm just printing out the payload, Python serializes that byte string and kind of tells me, like, this is a byte string. So it's a little bit easier to catch that. But it's just one little annoying thing that I'm sure as you use Python 3, you'll get a lot more familiar with this over time, but it's a little bit new to me because I've really only just now started to really get serious about using Python 3. So, okay, so if we get that toggle, then let's toggle our LED. So let's do gpio.output, and let's do so we want to read, first I need to do my LED pin, and then I want to read gpio.input on my LED pin. So same kind of toggle logic, but then I want to invert that, so we'll do not. And that should be okay, so let's save that. And then let's also just put in the on and off commands too, because those are, it's easy, it's just a few extra lines here. So if our payload equals on, then let's just do gpio.output LED pin gpio.high. So high logic level, and then if we receive off, let's do the right thing for that. So we'll say off, and gpio dot output LED pin, and make this gpio dot low. Okay, cool. So that's our logic there. Now let's just go for broke. Let's add the logic to listen to button presses. So like I said before, though, again, it's the same kind of problem we have with the socket server, where this loop forever is blocking and it's never going to return. And we want that because you need some loop somewhere that's waiting for these messages. And now you saw the way we solved that with the socket server, we actually created a background thread. The really nice thing about the Paho library, they know that that's probably what a lot of people want to do, so they actually have a loop start function which will just go and create a thread in the background for you. So I can call this, it's going to make a background thread. That thread's just going to serve all of the MQTT messages. So it's, it's going to handle like the on connect and the on message automatically for you. So this is great. Like it's simple. I wish the Python standard library was like this too. It would make it a lot easier. So okay, so now I basically just need my main loop for listening to button presses. So I'm just going to copy that out of the code down here, and then let's just kind of tweak it a little bit to have the logic that we need. So okay, let's uncomment that and fix the indenting. So okay, so we'll say the server, and it's not really a server anymore. We'll say the script is running, and now same logic like we had before. You take 2 button press readings, you wait a little bit of time in between there to see if the button's been pressed, and then when you detect that high to low transition, the button's been pressed. Now our logic is, instead of using a socket connection, I just want to publish a message to my MQTT server, and luckily that's really easy. So that client object actually has a publish function you can call on it, and it just takes the topic and the payload that you want to publish. So the topic that I want to publish on is the /LEDs/ESP8266, and then the payload, I just want to send it that toggle command. And yeah, let's keep it just like this, and then let's just delete all the code that's not used down here. So okay, so now you can see here's our main loop. Just listen for the button press, and when I receive one, do the client.publish on the LED topic and the ESP8266, and then send it that toggle message. So okay, let's save that, and let's run our script. So I'm just going to Control-C out of that. There we go. And now let's run our server. Oops. Oh, I forgot to. I removed the time library, but I'm still using it. So let's import time at the top. So there we go. And now, okay, so now we're running, and let's just see. So I'm going to press the ESP button, and remember, I put in the code where now it should listen, and if it receives that toggle command, we should hopefully toggle the LED. So let's see what happens. Hey, look at that. So you see, it printed out the message still, and then it also toggled the LED. And so now let's try from the Pi. So I'm going to press this, and hey, look at that. It turned on. It toggled it. And so, and you can see, we detected the button press, and then it toggled it and sent that command over there. So we've pretty much done what we wanted to do here. We've converted everything over to use the Raspberry Pi as a little broker that's sending and receiving these messages, so that it's pretty cool. And the neat thing is, because this Pi is a central server, I can have other stuff control these LEDs. Like, let's go to my Mac right here, and let's publish ESP. Let's turn it off. Let's say let's turn this LED off. And boom, look at that, it sends it. And maybe I want to turn on my Raspberry Pi LED. So let's just do the publish command, and let's change it to the /pi path. And look at that, it turns on. So that's really cool and really powerful. And that I can have all kinds of scripts running on all devices around my home. And as long as everything follows whatever convention I define, like, this, I have this hierarchy of topics like /LED/ESP8266, I could have all kinds of devices, and as long as things know like what path to talk to, what topic to talk to, they can talk to other things. And the other important thing here too is that it's this central server on the Raspberry Pi that everything is connecting to. So, again, my code is a lot simpler. Like on my ESP board, it doesn't need to listen for socket connections and send and receive data. It just needs to know how to talk to that MQTT server. And likewise, like when I want to publish a message from one device to another device, as long as they're talking to the same broker, the same Raspberry Pi, they can talk to each other without directly connecting to each other. They're just telling that broker, hey, here's a message for this topic, send it off to whoever's listening. And the cool thing is, like, my devices don't even have to know what other devices are listening to them, which is a really powerful thing, because you can imagine, like, if my ESP code had to know every other device that it wanted to talk to, well, as soon as I add another device, now I've got to go update my ESP code to go talk to that device. Whereas here, it's like the ESP code only knows how to talk to the broker, the server, and then it's up to whatever devices want to connect to that server to receive those messages. So a real powerful kind of abstraction to think about here, that your code isn't so tightly coupled to all your devices. Your code is more coupled to the MQTT server, and then all kinds of devices can connect to that server and send and receive messages there. So I think that's it. I mean, this is pretty much the demo that I wanted to do, and really this whole series, we've kind of capped off different ways to talk, to have these Wi-Fi boards talk to a Raspberry Pi, to both send and receive messages here. So if folks have questions, maybe throw them into the chat, and I'll see if I can answer them. Let's see, we'll jump back to the main kind of view right here. Let's see. And I don't see a lot of questions here. Yeah, there's a little bit of stuff going on before here. So yeah, but yeah, throw the questions in right now. But I'll just kind of summarize. So the series. So I'll wrap up this series. This is the 4th video on this, and the very first video, if you go back to that one, we kind of saw how you could use the netcat command to receive data from an ESP board. Just real simple, like there's no code at all on the Raspberry Pi. We're just using netcat, receiving data and saving it to a file. Real simple, but it works. Like if you have sensor data that you just want to blast out to the Raspberry Pi, something simple like that is great. The second video, we looked at how to have the ESP board receive commands from the well, actually not even from the Raspberry Pi, but from netcat, which was running on the Raspberry Pi. So a simple way, without using code again, to send data to the ESP board, just using raw bytes of data that we're sending with netcat. Then the third video, the last one, we looked at how to build a little socket server, so Python code that runs on the Raspberry Pi and sends and receives messages with the ESP board. And so you could see, some basic socket programming with that. And then in this video, I showed, okay, how to do all that using MQTT, where you're running a broker server on the Raspberry Pi that knows how to talk this MQTT protocol, and then all of your devices connect to it. So like a script that runs on the Raspberry Pi, or code that runs on your ESP board, all of that connects to the same broker, and then everything can send and receive messages to each other because they're talking to that same server. And so we saw how that really simplified the code. Like, my Python code, I just removed all that socket server logic and just have some real simple little callbacks using that PAHO library. And so that's why I think, it's good to end on this video for the series, because it shows, like, okay, when you want to approach a problem of having multiple devices talking to each other, look at these higher level protocols and concepts like MQTT. And there are other protocols that you can use for this. There's one called CoAP. MQTT has a lighter weight version called MQTT-SN. So there are other things out there. But, that's usually how you want to approach a problem. Like, don't go and try and reinvent the wheel and build your own socket server if you don't have to. But at the same point, it's good to know those basics and to play with it and try it out and, see what the advantages and disadvantages are. So that's hopefully in this series we've kind of gone through a lot of those different things, and you've been able to see firsthand how that works. So okay, so it looks like some questions. Are topics created dynamically on the fly for MQTT? Yes, yeah. So topics, anything can publish any topic and receive any topic, at least for the Mosquito server as it is configured by default. I can imagine servers probably let you lock down, like maybe there's some explicit list of topics, but by default you can publish to anything and subscribe to anything. There's no like setup that you have to do to like say, okay, create this topic for Mosquito, which makes it nice. It's real dynamic, really easy to use like this. So I think that's it. I think, so one question for Secure Broker and ESP8266. Yes, that's a good question. So like I said before, the default configuration for Mosquito that I've set up is completely insecure. So like you don't want to put this Pi on the internet because anyone's going to connect to it and they're going to toggle your LEDs or, control your devices. And so maybe a future video, I might come back because I think MQTT alone is probably a whole series of videos. And that could be a really interesting thing. Like the Mosquito Broker, it supports lots of different levels of encryption and authentication, so you can definitely set things up to be secure. But just for now, I wanted to keep it simple. And if you're just using this within your own network, I think it's okay to do this. Like security people are probably screaming right now, like no way. But as long as you're not opening this up outside of your network, the risk is pretty low that someone's going to mess with it, because people need to know that the server is running. They need to know what topics are there. And also like be smart. Like don't put your pacemaker connected to your MQTT server that's completely insecure. That would not be a smart idea. So if you don't have something on here that you're not afraid of the internet taking over, then it shouldn't be too bad. So that's it. I think we'll wrap it up. We'll call this an end of the series. Subscribe to youtube.com/Adafruit. You can watch this video and all kinds of other videos. Twitch.tv/Adafruit. I stream these things live. I like to do a bunch of streams every week. So I do a Monday stream, a Friday stream, and I'm starting to do a third stream too. So the Monday stream, I look at interesting software. This Monday, I'm thinking of looking at Chromium OS on the Raspberry Pi 3. So that's Chrome OS, like you can buy a Chromebook. But that's an open source operating system, and there's a really cool project that's ported it to run on small board computers like the Raspberry Pi, and they just had a release a few weeks ago for the Pi 3. So I want to try that out and see, because the faster Pi 3, that could be a really cool, cheap and easy DIY Chromebook kind of thing. So I'm going to check that out Monday. And then Friday next week, we'll start some new videos. I'm not sure if I'm going to start a whole new series yet Friday, because 2 weeks from now I won't have a Friday video. I'll actually be down out at Maker Faire. So if you're out there, you might see me out there. But yeah, I won't be able to do a video. Maybe I might be able to do some live streaming. We'll see if the periscopes allow, but I'll definitely get some videos and pictures and things. But so next week, maybe we'll do a little one-off thing, and we'll see, look at a little topic. So that's it. Like, comment, subscribe. Let me know if this stuff is helpful. If people like it, that kind of keeps us all going, and keeps us all happy. And that's it. So I'm Tony from Adafruit, and thanks a lot for watching the Raspberry Pi Talking to Wi-Fi Things series. I'll see you guys later. I'll see you guys on Friday again. We'll look at something else.